Welcome to Techie Wise. In today's session, we will be discussing some additional numericals based upon the concepts of Fermat's theorem and discrete log. Okay, to start with, So here, this is one of the book back questions from a popular cryptography network security textbook by Professor William Stallings. So here 2 is the primitive root of 29. So we can construct the discrete log table, right? So construct the discrete log table and solve these 3 equations. So first task is to construct the discrete log table. Yeah, we can just construct it because 2 is a primitive root of 29. So using this discrete log table, we are going to solve these 3 equations. Okay, I have already constructed the discrete log table. You can try it out later. Using this table, now we are going to solve these questions. So now the first question is 17x square is congruent to 10 mod 29. So 17 6 square congruent to 10 mod 29. So all these are the values. Using these table, we are going to construct it. So what is 17? 17 is 2 to the power of 21 mod 29. So in place of 17, we are going to use the value 2 to the power of 21 x square, right? Now 10. So 10 is equivalent to 2 to the power of 23 mod 29. So 2 to the power of 23. So instead of 10, we are using 22 to the power of 23 mod 29. Now, so 2 to the power of 21 here and 2 to the power of 23. So now x square is congruent to 2 to the power of 23 minus 21. So which is 2 square mod 29. So what is, now we can easily solve it, right? So x is congruent to plus or minus 2 mod 29. So what are the possible values of x? So x can take the value of 2 mod 29. And what is minus 2? Minus 2 plus 29. So that is 27. So these are the possible values of x. Now the next question is x square minus 4x minus 16 is congruent to 0 mod 29. You can please try it out. Parallelly, we can proceed. So here, x square. So I'm going to rewrite this. X square minus 4x is congruent to 16 mod 29. I'm going to try to bring this equation of the form x minus a the whole square. What is x minus a the whole square? X square minus 2ax plus a square, right? I'm going to try in that form. I'm going to try making this equation in this form. So now x square minus 4x plus 4 is congruent to adding 4 both the sides. So 20 mod 29. So what is x square minus 4x plus 4? So this is x minus 2 the whole square. So here 20. So what is 20? 20 is 2 to the power of 24. 2 to the power of 24 mod 29. Taking square root in both the sides. So this is x minus 2, which is congruent to 2 to the power of 12 mod 29 plus or minus. Plus or minus 2 to the power of 12. So x minus 2 is congruent to what is plus 2 to the power of 12? 2 to the power of 12 is 7. So plus or minus 7 mod 29. So now what is the possible values of x? x is possible values is 9 mod 29, and another possibility is x is congruent to -5 mod 29. So first is we are, yes, so here we are trying out with the two possibilities of 7. That is, first is x minus 2 is congruent to 7 mod 29. So 7 plus 2 is 9. So that is 7 plus 2 is 9. And another possibility is -7. So -7 plus 2, which is -5, which is equivalent to, what is that, -7 plus 29. So which is 24 mod 29. So now we can proceed with the next equation. So what about the next equation? X power 7 mod 17. We can try it out here. X power 7 congruent to 17 mod 29. So what is x power 7? What is 17 here? So from this table, 17 is 2 to the power of 21. So x power 7 is congruent to 2 to the power of 21 mod 29. So here 21 can be rewritten as 2 to the power of 3 power 7 mod 29. So here it is x power 7 and here it is 2 to the power of 3 power 7. So what is 2 to the power of 3? 8. So x power 7 is equal to 8 power 7 mod 29. So what is the value of, so here we have solved the equation, right? So x is 8. So the next what we are going to discuss is a numerical with using Fermat's theorem. So the question is, using Fermat's theorem, find 4 to the power of 225 mod 13. We used to deal with this with the help of modular exponentiation. So here we are going to apply the Fermat's theorem to easily solve this. So what is Fermat's theorem? If P is prime, so here in this case, 13 is prime, P is prime, and A is a positive integer not divisible by P. Yeah, 4 is a positive integer which is not divisible by P. So then what is the property? A power P minus 1 is congruent to 1 mod P, right? So we are going to use this property to solve this equation. So here 225. So here the thing is 4 to the power of 225 mod 13. Right. So here we are going to bring it in this particular format. What is that format? A to the power of P minus 1. That is 4 to the power of 12. That format we are going to try bringing it out. So 225 can be written as 2 to the power, 12 to the power of, that is 12 into 18 plus 9, right? 12 into 18 plus 9 is 225. So how we can write now? 4 to the power of 225 mod 13 can be rewritten as 4 to the power of 12 power 18 into 4 to the power of 9 mod 13. We are using this property A to the power of B plus C is equivalent to A power B, A power C. The same property we are using here, right? So now what is 4 to the power of 12? Already we have by this the proof is 4 to the power of 12 will be congruent to 1 mod 13. So we have already identified this value, calculated this value with the help of the Fermat's theorem. So 1 power 18 is 1. So the entire part will become 1. So now we can easily solve this equation. So now our equation is reduced to 4 to the power of 9 mod 13, which is equivalent to 12. So this is how we can make use of the Fermat's theorem. So we can see one more example with the, applying the Euler's theorem. So using Euler's theorem, find x whose values falls between 0 and 14 with x power 57 is congruent to 7 mod 15. X power 57 is congruent to 7 mod 15. So now we are trying to find the value of x. So what is Euler's theorem? A power 5 of n is congruent to 1 mod n. So here n is 15 and a is x, right? So now in order to proceed with, we have to find the phi of n. So what is phi of 15? Phi of 15, or already we discussed the property if n can be factorized into 2 primes. So here in this case, n can be factorized into 5 into 3. So which is 5 minus 1 into 3 minus 1, which is equivalent to 8. So phi of 15 is equal to 8. Now we can apply the property here. So according to the Fermat's theorem, x power 8 is congruent to 1 mod 15, right? So already we discussed what is phi of n. Now n is 15. So according to the property of Euler's theorem, x power 8 is congruent to phi of n. X power 8 is congruent to 1 mod 15. So now we are going to apply here. So what is 57? So 57 can be written as 8 into 7 plus 1. 57. 57 can be written as 56 plus 1, right? Now we are going to use it here. So x power 57 can be written as x power 8 power 7 multiplied by x, which is congruent to 7 mod 15. So this is the equation, right? 7 mod 15. So what is the value of x? X is equivalent to 7. So because this entire part is equivalent to 1, so x is equal to 7. So this is how we can use this Euler's theorem to solve this particular equation. Thank you.